right, this is physics lesson 6.06 on centripetal force with some sample problems. You might want to pause the video and copy these down. All right, so we've got two problems. If you're on a merry-go-round with a radius of 17 meters and a tangential velocity of 11.2 meters per second, what is the minimum coefficient of static friction between your shoes and the merry-go-round? The first thing you might be saying to yourself is, boy, that's not a lot of variables, and you would be correct. But it is enough for us to be able to solve for what we need. We have to go back and we have to consider the fact that we have a force that is keeping us moving in a circle. So if somebody came in and they greased the merry-go-round and then started to spin it, you would just fly right off. And at the point that it's spinning, you would fly off at a speed of 11.2 meters per second. So what's the force that's holding you there? Well, the force is friction. So we could say that friction is supplying the centripetal force. So if I find the centripetal force, that is going to be equal to the force of friction. Now, what do we mean by that? That means that this is the maximum, how do I want to say that? The maximum friction that we need to keep us moving in a circle. If I have less friction, that's okay. But if, I'm sorry, if I have more friction, that's okay. But if my friction drops below this value, it won't be enough to keep me moving. So I'll lose the ability to move in a circle. And we expanded these. We know the force of friction. In this case, we're looking for static friction is equal to mu sub s times F sub n. And we know that centripetal force is mass tangential velocity squared over radius. Well, you might be saying to yourself, okay, I've got this and I've got that, but that's a far cry from mass and I'm solving for this. Well, remember, I can bust this equation out even further. So if this is you and you're on the merry-go-round and you might go flying off tangentially this way, you've got no vertical motion. Are those even? I try to make them even. So F sub W and F sub N, it's going to be positive and that's going to be negative. So F sub N has to be equal to, and we know F sub W is equal to mass times gravity. So if I take this and create an equivalency here, I can bust this out again. So now I have mu sub s mg is mvt squared over r. So look at how many equation substitutions I did here. I started off with this basic equation, and then I expanded it even further, and then I did another expansion here. And I call this formula flexing. And this is what we're going to have to get much better at before the AP test time, because they ask you to do this quite often. When I look at this, I've got mass on both sides, so that's going to cancel out. And my equation that I'm going to end up using is, let me stick with red, mu sub s times little g is tangential velocity squared over r. Now I have this, this, and this. So it's going to be mu sub s times 9.81. It's going to give, and it's going to be equal to 11.2 squared over 17. And when I solve, I end up with a coefficient of static friction of 0.75. All right, how about example number 2 here? What is the tangential velocity of a rocket orbiting the planet Jupiter at 20,000 kilometers? Well, here I have, I'm moving in a circular motion, and so I'm going to have centripetal force. Well, what's going to be providing that centripetal force? It's going to be the force of gravity. I could split this out to be m, and this is going to be the mass of the rocket. So we're talking about the centripetal force acting on the rocket. So we're going to have mass of the rocket, tangential velocity of the rocket over r. And over here, I'm going to have Newton's constant, mass of the rocket. It's going to be, the second mass is going to be the mass of Jupiter over R. Well, we need to talk about, first of all, R. So if I have the planet Jupiter here, and I have my satellite, it's going around Jupiter. I have 20,000 kilometers here. And then I have another distance. It's the radius of Jupiter. Now, did you notice, first of all, I've got a unit mismatch. So 20,000 kilometers, this needs to go to meters because my base unit is always meters. So this is going to be 2.0 times 10 to the 7th meters. So to get my total distance R, that's going to have to be the radius of Jupiter plus 2 times 10 to the 7th meters. And that oops. Let me clean this up a little bit. That's squared. Now in this case, R and this and D are going to be the same thing. So I can simplify this a little bit. I've got the mass of the rocket on both sides. That's going to cancel out. And when I simplify this equation, I end up with Newton's gravitational constant times the mass of Jupiter over the radius of Jupiter plus 2 times 10 to the 7th meters. That's going to be equal to my tangential velocity squared. And that's squared over there. And that's going to be over the radius of Jupiter plus 2 times 10 to the 7th meters. One of the things, another thing that the AP test will ask you to do is to write an equation for something in terms of, they'll say solve or create an equation for tangential velocity. So if I was going to leave this in algebraic terms, that's something again that is commonly done. I could say that I have Newton's gravitational constant times the mass of Jupiter over Rj plus 2 times 10 to the 7th meters squared. And to get tangential velocity by itself, I'm going to multiply both sides by this expression. So that's going to be Rj plus 2 times 10 to the 7th equals Vt squared. This term is going to cancel out the square, and this is just going to be Rj plus 2. And I'm just going to go, well, 7th. And then to get the square off there, I'll have to square both sides. And my final expression would be Vt is the square root of big G, mass of Jupiter, over radius of Jupiter plus 2 times 10 to the 7th. So that's another thing that we need to get used to is leaving answers in the terms of the variables. This is a constant. This is going to be 6.67 times 10 to the minus 11th. We could look these up on tables. In fact, I think when we do, we end up with an answer of something. It's like it equals the tangential velocity is going to be 37,231 meters per second. But it's not uncommon to give an answer like this. So let's buff up your algebra skills a little bit in terms of working with variables. All right, the next problem is going to be a longer one, probably about a 15-minute one. So I'm going to split this into 2 videos. I'm going to stop this one here, and we'll do centripetal force on a banked curve as our last sample problem.